Hello friends, so we have a question on geometry. We are given two airplanes with their position vectors RE and RB with respect to an origin, where T represents the time in minutes. This T is basically a parameter which is time in minutes, and time is varying from 0 to 2.5 minutes. We have to identify the three-figure bearing on which airplane B is traveling. So before going forward, let us try to understand what does this particular sentence mean. This means that in any column, suppose in case of B it is given 1, 0, 12, the first entry is basically the displacement east of O. The second entry is the displacement north of O. And the third entry is the distance above sea level. So this is east of O, this is north of O, and this is above sea level. Now, we have to identify the three-figure bearing. What do you mean by three-figure bearing? Three-figure bearing is basically the direction in which airplane travels with respect to the north. So it is basically a standard way of identifying the direction in which the plane is moving. So, to identify the three-figure bearing, let us see what is the RB. The RB given to us is 1012 plus 4, 2 and minus 2. So this is the vector at any time t. Now the third part is the height from sea level. So now we have to identify the direction from north. So we will consider only east and northern part of this particular information. So this information says that the plane started from 1, 0. This is east and this is north. And at any time t, it is at 4t, 2t. Now, the three-figure bearing or the bearing angle is basically the angle with respect to north. So at the starting point, it was 90 degree. Now at time t, if you see, this is the phi we needed to identify. Now we know if this is angle theta, phi or the bearing angle can be identified as 90 degree minus theta. So this will be 90 degree minus theta is basically arc tan 2t by 4t. So this will be 90 degree minus arc tan 1 by 2. So this will be 90 degree minus arc tan 1 by 2 is nothing but 26.57. You can use your calculators. So this will be 63.43, or we can write it as 063 degrees. This is point, so you have to convert this. So the more particular way will be 063 degrees. Now let us move on to the B part. In the B part, we have to show that the airplane travels at a greater speed than airplane B. So if RA for the A plane is 19 minus 1 plus T multiplied by minus 6 to 4, you can know the velocity for this will be first derivative, so that will be minus 6 to 4, and the speed will be the modulus of VA, which will be root under minus 6 square plus 2 square plus 4 square. So this is root under 56, which is approximately 7.48 kilometer per minute. Now, what is RB. RB is 1, 0, 12 plus T times 4, 2 and minus 2. 2 and minus 2. So VB will be its derivative, that will be 4, 2 minus 2 with respect to derivative with respect to time. So the speed modulus of VB or root under 4 square plus 2 square plus minus 2 square, which will be root under 24 or 4.89 kilometer per minute. So you can see the velocity of A is greater than the velocity of B. So we have to show that the air travels at a greater speed than the aeroplane B. So the speed of A, which is 7.48, is greater than the speed of B, which is 4.89. So now let us move on to the C part. In the C part, we have to identify the acute angle between the two airplanes' line of sight. So the acute angle between the two airplanes' line of sight or will be, suppose, say cos theta, which can be identified as the dot product of RA and RB. The line of sight angle will be, for RA it is minus 624, so it will be minus 624 dot, and for RB it will be 4 2 minus 2 divided by their modulus, which is root under minus 6 square plus 2 square plus 4 square root under 4 square plus square minus 2 square. So this basically comes out to be minus 6 into 4 plus 2 into 2 plus 4 into minus 2 divided by root under 56 into root under 24. So this comes out to be minus 7 by root under 84. You can further simplify this. So theta will be coming out to be, so cos theta basically comes out to be minus 0.7637 and theta will be equals to 2.4399 radians. You can convert this into degrees. This will be multiplied by 2.4399 into 180 by pi degrees. Or if you want to identify the acute angle, we can subtract this from 180 degree minus theta. So this will be coming out to be, simplifying this you will get 139.96, or this will be approximately 40 degrees. Let us move on to the D part. In the D part, we have to identify a particular point P where the flights cross each other. So flights cross each other, that means the position vector of both the flight must be same at that particular position vector P. So we know the path of RA, that is the plane A, will be given by 19 minus 1 1 plus T into minus 6 2 4, and for the plane B the path is given by 1012 plus T into 4 2 minus 2. Now suppose at T1 the plane 1 is at a particular point P, and at T2 the plane B is at a particular point T2 at T2. So we have to equate these two position vectors to find the values of t1 and t2 such that that position vector is common to both the flight paths. So putting t1 in this, we will be getting 19 minus 61 equals to 1 plus 4t2. Second equation will be minus 1 plus 2t1 equals to 0 plus 2t2, and the third one will be 1 plus 4t1 equals to 12 minus 2t2. So we have three equations in t1 and t2. You can solve these equations taking any two and then the solution satisfying in the third. The value of t1 will be coming out to be 2 and the value of t2 will be coming out to be 3 by 2. So these for the plane A are 2 minutes and for the plane B at 3 by 2 minutes the position vectors will be same. And what will be that position vector? You can put t1 in RA or t2 in RB to identify that. So for example, putting in RA, you will be getting is 19 minus 1 plus 2 times minus 6 to 4. So you will be getting is 19 minus 12, that is 7, minus 1 plus 4, that is 3, 1 plus 2 into 4, that is 9. So this is the position vector P, where both the planes will be crossing each other, that is their flight paths will be crossing each other at different times. So in the second part we have to identify the time gap in which both the planes will be crossing this position vector P. So we know the plane A comes here at 2 minutes of its flight and plane 2 comes at 3 by 2 minutes. So plane B comes earlier than plane A, and how much time it comes earlier? That is 0.5 minutes. Now let us move on to the E part. In the E part, we have to identify minimum dt, which is the distance between A and plane B. So we can identify the distance between A and plane B at any time t by using their position vectors. So this will be 19 minus 1 plus t times minus 6 to 4 minus plane B will be at any time t will be at 1012 plus t into 4, 2 and minus 2. So RA minus RB comes out to be 18. 19 minus 1 is 18. 19 minus 1, 18. Then minus 1, minus 0, minus 1. Then 1, minus 12, minus 11 plus t, that is minus 6, minus 4, that is minus 10, 2 minus 2, that will be 0, then 4 minus plus 6. So dt will be basically the modulus of this vector. So that would be root under 18 minus 10t square plus minus 1 square plus minus 11 plus 60 square, and it will be minimum when d dash t will be equals to 0. So finding d dash t, the first derivative of this particular expression, it will be 2 times divide 2 root under 18 minus 10t square plus minus 1 square plus minus 11 plus 6t square, and then differentiating these terms 2 times 18 minus 10t into minus 10. The differentiation of minus 1 will be 0. The differentiation of this term will be 2 into minus 11 plus 6t into 6, and then equating it to 0, you can solve this for t, and you will be getting t equals to 1.8088, and at this particular t, dt can be identified using this particular equation, and the dt will be coming out to be 1.01459 kilometers, or approximately say 1.01 kilometers. So this is your solution, and for more such questions, do visit our website www.iitnacademy.com and register for detailed explanations and solutions. Thank you.